Chapter 15, Computing Probabilities. We will begin with section 15.1, Sets and Venn Diagrams. We have an example here, but before we get into that, let me just show you what the idea of a Venn diagram is up here in the space at the top. In a Venn diagram, we draw a rectangle, and that represents some sort of big set of things that we're talking about. And then inside of that, we draw circles that represent events that are part of that. And there's kind of three main ways this can go. Inside your box, and when you have these two circles, the most common thing that can happen is the two circles overlap like this, which means that they have some things in common but some things apart from each other. And then another scenario is the two things can be what we call mutually exclusive. We'll define that later. But that means they don't overlap at all, so it's not possible for both of them to happen at the same time. And then squeezing it in over here, a third possibility is one event is completely contained inside of the other, so that all of these are always this type. So these are the three kind of configurations we want to be thinking about as we approach these examples. So we'll make a little more sense out of those as we have the specific examples to consider. So draw Venn diagrams with two circles showing the relationship between the following pairs of sets. And the first thing they want us to handle is nurses and skydivers. So what I'm going to do is start off drawing the rectangle, and then I'm going to label that as some big group that contains nurses and skydivers. And I think something fairly generic that would do that would be people. So all nurses are people, all skydivers are people, so they're going to fit inside of this box. And now what we have to think about is, are there some nurses that are skydivers and we should draw a picture like this? Is it impossible for somebody to be a nurse and a skydiver? Then we draw something like this where the circles are separate. Or is it the case that all of one lives inside of the other? Do all nurses skydive? Are all skydivers nurses? So let's handle that in reverse order. Are all skydivers nurses? No. Are all nurses skydivers? No. Are they completely separate? Is it impossible for a nurse to skydive? No, that's not possible, or not impossible. So I think it's going to be this one, kind of by process of elimination, that there's some overlap but not complete. So to help us kind of see what's going on, I'm going to use two different colors. So I'll do nurses are red. So here's the circle that represents nurses. And then I'm going to do skydivers in purple. And we draw that one there. So, and then we want to label it. So not just the color coding. So we have nurses for the red circle. And then for the purple circle, that's going to be the skydivers. I'll just put a S.D since that's kind of long to fit in there. But the idea is that we have people that are neither nurses nor skydivers. So they'd be in the box, but not in either circle. We have most skydivers who probably are not nurses would be out here in this part. We have most nurses who are not skydivers would be over here in this part. But then there's got to be at least one skydiving nurse out there. It's certainly a possibility, right? When we draw these also, we don't worry about the size. So there's probably not a high percentage of nurses that skydive. We don't worry about how big this overlapping section should be. We just want to show that that is a possibility. All right, so let's move on and try the next one. Reptiles and bacteria. So we draw a box and we try and think of some bigger category that reptiles and bacteria both fit into. So how about living organisms? So reptile is a living thing, bacteria is alive also. And then we'll do the same sort of idea. We'll do the reptiles in red. And then how about, just because it's the way I think of it, we'll do the bacteria in green. And then we want to think about, of these scenarios up here, which one fits. So is there some overlap? Are there some bacteria that are reptiles, but not always? Are they completely separate? Are all reptiles bacteria? Are all bacteria reptiles? And to the best of my knowledge of this setup, the one that works would be this one right here. So there is no kind of reptile that's also considered to be a bacteria. There's no kind of bacteria that's considered to be a reptile. So they're both living organisms, but they don't have an overlap. Certainly one is not inside of the other, so I would draw them as two separate things. So we would have a circle representing reptiles, And then we draw another circle representing the bacteria, and they would not overlap. And again, we don't worry about size. We don't think about which one of those is there more of, and we better make that circle bigger, and what percentage of living organisms are reptiles. We're not considering that here. Venn diagrams are just to show possible relationships and kind of how the things interact with each other, but not to show proportion. Okay, so keep that in mind. Don't try and factor that in at all. Just try and draw the different types of relationships and think about these three possibilities. Do we have overlapping? Do we have mutually exclusive, which is when they're kind of distinct, separate cases like this, or do we have one lives inside of the other, which comes up sometimes too? Like, for example, every German Shepherd is a dog. So if we had that as our two lists, then the inside one would be German Shepherds, the outside one would be dogs, and then the big box maybe is animals or something like that. All right, our next example, draw Venn diagrams with 3 overlapping circles, which will be 8 regions altogether for the following groups of 3 events: hockey players, figure skaters, and women. All right, so what we're going to do, we have a lot of space here, so I'm going to draw a pretty big box for our Venn diagram, and then we want to come up with some description we can put on that box that contains all of these different things. And I think one of the ones we used up above would be fine, so we could say people. Hockey players, figure skaters, and women all fit into that box of people. We can go ahead and do some color coding again. We'll do hockey players in red, and I'll do the figure skaters in green, and then we'll go ahead and use this teal color for women. So we want there to be 8 regions, and they want all things to have the possibility of overlapping. So let me just show you how we do that. So we make our first kind of big circle here. So there's our hockey players, and then we bring in the figure skaters, and we do that like this. So far it's kind of like just our overlapping circles from up above, but then we're going to draw a third one that overlaps through all of these regions as well. So like this. So there's our 3 overlapping circles. Did we really get 8 regions? So we have this outside region 1, and then 2, 3, 4, 5, 6, 7, and then this middle part where all 3 overlap would be 8. And let's label them. They're just abbreviations here. So we've got hockey players right there. We've got our figure skaters right here. And then we've got women down here. And then they didn't ask us to do this, but I just want to talk about what all 8 of the regions are. So let's start off with this triple overlap. That's in every circle, so it fits every description. So that is a person that is a woman. She figure skates, and she plays hockey. If I go to this section right here, that is the overlap of women and figure skaters, but it's not in the hockey player circle. So this would be a woman who figure skates, but that does not play hockey. If we go up here, this is a hockey player who figure skates, but is not a woman, or it's a hockey player who figure skates that is a man. Can come over to here. This is a hockey playing woman that does not figure skate. So notice that when we're not in a circle, that tells us something as well as being in the circle does. This is in the circle for figure skating where I'm pointing, but not in the hockey player or woman circle. So this is a figure skating man who does not play hockey. Here are women who do not play hockey or figure skate. Here are men who play hockey but do not figure skate. And then what about outside? That's somebody who's not in any of those circles. So that would be a man who does not play hockey and does not figure skate. All right, so that's as complicated as we're going to make it in this class, but you could end up adding 4th and 5th circles too, and it just gets more and more relationships. But the Venn diagram shows us a way to illustrate those all in a small picture. All right, let's look at another example. Use the Venn diagram to answer the questions that follow. So we have people at a party. Some of them are men, some of them are women, some of them are under age 30, some of them are not. So let's answer the questions that they have for us. How many men at the party are under age 30? So they only want us to count men, so we can only count people if they're in this circle for men, which is these 12 people and these 15. But we also want them to be under 30, and these 22 people right here, these 22 men, are not in the circle for under 30, so it would just be these 15 right here. Right? Those 15 people are men because they're in the men's circle, and they're under 30 because they're in the under age 30 circle. All right, let's try another one. How many women at the party are over 30? So the women would be anybody who's not in the man circle. So these 28 people and those 16 are all the women, but we don't want all of them. We only want the ones that are over 30. So we don't want these 16 because they're under 30. Let's look at it this way for a minute. Where are the women in our chart? We have 28 right here plus 16 right there. Everybody who's not in the men's circle would be a woman. And then why don't we add all of those together like I've written here? Well, because we only want the ones that are over 30, so we don't want the ones that are under age 30, and that's these 16 women right here, so we'd get rid of those, and we just have the 28. How many men are at the party? Okay, so notice right here, they just want to know how many men. They don't care what age they are, so we would add everybody that's in the man circle, and that's the 22 here and the 15 there, regardless of age. So 22 plus 15. And we get 37. And how many people at the party are not under 30? Okay, well, how many people are under 30? These 15 and those 16. So how many people are not under 30? That would be everybody except for these 15 and 13. So that'd be these 22 men and those 28 women. Notice we add together the men and the women. They didn't say anything about gender, so any gender is fine there. We just want to make sure they're not under age 30, so we don't want these 15 or 16 that are represented in that circle, but just these 22 men and those 28 women, and that's 50 people altogether. All right, so there's a little bit more practice with the Venn diagram. This one was already made, but we had to be able to look at it and realize what section represented what. It takes a little bit of practice, but once you get the hang of it, these are nice, quick, easy problems to do in homework and on quizzes, and hopefully on the final exam as well. All right, another example. Use the Venn diagram to answer the questions that follow. So let's look at the Venn diagram first. We have people at a conference. We have men and women. The women are in the circle. All the other numbers that represent men. We have people who are currently employed. That's all the people inside this circle. Everybody on the outside of that circle would be unemployed. We have those who have a college degree. That's everybody inside of this circle. All the ones on the outside would not have a college degree. All right, so how many people at the conference are employed men? So we want them to be men, and we want them to be employed, and we're not worried about whether they have a college degree or not. So we want the overlap of the men circle, I was going to say, but there's not a man circle. So all these people are women. So let's start off by listing all the men, okay? So if you're not in the circle for women, then it's a man. So 9, 16, 6, and 3. So 9, 16, 6, and 3. Those are the men because they're not in the circle for women. But we only want employed men. So of the 9, the 16, the 6, and the 3, which ones are employed? Only the 16 and the 6 are in that employed circle, so we can cross off the 9 and the 3. So it looks like it's 16 plus 6, or 22 employed men. Let's just double check those to make sure that it works. Those 16, they're men because they're not in the women's circle, and they are employed because they're in this circle. These 6 are men because they're not in the women's circle, and they're employed because they are in the employed circle. And why not these 8? Because they're women. Why not those 11? Because they're women. Why not these 9 men? Because they're not employed. Okay? So always think about that. If you have a number that you think fits, just double check to see what its description is and see if it violates some part of that or not. Let's try the next part. How many people at the conference are unemployed women? Okay, so this time they want women. So let's start off by listing all the women, everyone inside the women circle. So 4, 20, 11, and 8. Those are all the women. We only want the unemployed women. So if they're in the currently employed circle, we don't want them. So we don't want the 8 or the 11 because they're in the circle that's labeled as employed. So these 4 and these 20 are women, and they're unemployed because they're not in the currently employed circle. So it'd be 4 plus 20, or 24. All right, next one. How many people at the conference are unemployed men without a college degree? So we've got lots of things going on here. We know they're men. we know their employment status, and we know whether or not they have a college degree. So let's start off listing all the men like we did before. So that was the 9, the 16, the 6, and the 3, everybody who's not in the women's circle. So 9, 16, 6, and 3. But we want them to be unemployed. So if they're in the employed circle, let's cross them off. So that would be the 16 and the 6. And then we want them to be without a college degree. So if they're in the college degree circle, we don't want them. These 9 men right there have a college degree. We want ones that are without a college degree. So it looks like we're just left with those 3 guys right here. And do they meet all those descriptions? Are they unemployed? Yes, because they're not in the employed circle. Are they men? Yes, because they're not in the women's circle. Are they without a college degree? Yes, because they're not in the college degree circle. So those 3 all fit the description. And we just got one more to go. How many people are at the conference? Well, they're not talking about gender. They're not talking about their employment status. They're not talking about whether they have a degree. So they're talking about everybody that's in that box. So we would just add it all together. We could take the women, 4 plus 20 plus 11 plus 8. We listed those right here already for the women, but they were inside the women's circle. And then the guys, so there's the women. We'll add on the men. There was 9, 16, 6, and 3. And that's all 8 of the regions accounted for. And so the only thing left to do at this point is figure out what the total is. So bring in the calculator and just add those up real quick. And I'm getting 77 people. 1, 2, 3, 4, 5, 6, 7, 8. All right, so it looks like 77 people at the conference. So just adding up every single one of the numbers from that Venn diagram. All right, on to the final example. In a trial of a new allergy medicine, 120 people were given the medicine and 80 were given a placebo. Of those given the medicine, 90 showed improvement in their allergies, and of those given the placebo, 20 did not show improvement. Illustrate this situation using a Venn diagram. All right, so let's go ahead and start off by drawing our rectangle, and we'll give that a label that represents everything that's possible here. So let's see. This is a trial of a new allergy medicine, and so we have some people getting the medicine, some getting the placebo, some people showing improvement, some people not. Let's just call this people in the study. Or people in the, did they call it a trial? Yeah, people in the trial. And then I'm going to make 2 circles. One of them is going to be for people who got the medicine. So, yeah, let's do that. So when you do that, it's common for people to think, all right, so the next thing is going to be a circle for people who got the placebo. But we already have those people represented. Everybody in the trial either got the medicine or the placebo. So here's the people that got the medicine inside the circle. Everybody on the outside of that would have gotten the placebo. So you don't draw another circle about the treatment they got. You draw another circle about whether they improved or whether they didn't. So I'm going to make this green circle right here be people who improved. And again, I don't need a circle for those who didn't improve, because if you're not in the improved circle, then you did not improve. So we've got 4 regions there, and now we want to fill it in using these numbers. So there were 120 people who were given the medicine. So where do we put the 120? Well, that's a little tricky, because the 120 is the total for the red part. And so if I put it here, it looks like there's 120 people who got the medicine and didn't improve. If I put it here, it looks like there's 120 who got the medicine and did improve. We have to figure out how to split that up. So we'll hold on to that thought for a minute. There were 80 who were given the placebo, so there's going to be 80 outside of the medicine circle. Of those given the medicine, okay, so of the people in the red circle, of the 120 that are in here, 90 showed improvement. That would be, let me get a new color here. That would be right here. Because it says of those given the medicine, so the 90 has to be inside the red circle, but it said 90 showed improvement, so it has to be in the improved circle also. So those 90 have to have been given the medicine and they had to have improved, so they have to be in the overlapping part right there. Now we already know there was 120 given the medicine. So if 90 of them are here, then the other 30 of them, 120 minus 90, must have not improved and be in this part of the circle. All right, so we're going to try to do the same strategy for the 80 people who are given the placebo. So there's 80 between this region and this region, which are the two that we haven't put a number in yet. So of those given the placebo, which is everybody outside of this red circle, 20 did not show improvement. Did not show improvement. So those 20 I'm going to put right here. Let's make sure that fits. Were they given the placebo? Yes, because they were not given the medicine. Did they improve or not? They weren't in the improved circle, so they must have not showed improvement. Now, it said there were 80 who were given the placebo. There's 20 of them, so there must be 60 more, and those 60 must have improved. All right, that right there completes this question. They just wanted us to label all of the situation. So we've got the medicine, the placebo outside of that, improved and not improved outside of that. And we've broken down the 120 that got the medicine into improved and didn't, and the 80 who got the placebo, we've broken into 60 who did and 20 who did not. So it's done. But they're kind of missing the main question, in my opinion. And the main question is, does this new allergy medicine work? So how do you approach a question like that? Well, let's do this. Let's look at people who got the medicine and let's see the percent that improved. So let's do percent improved. So there were 120 people who got the medicine and 90 of them improved. So that's 90 out of 120. And if you do that as a decimal, that's 0.75. So 75%. So your first thought should be, looks like the medicine works because 75% of the people who took it, their allergy symptoms got better. All right, so I'm going to disagree with that statement though, because let's look and see what happens with the placebo. Of the placebo, there were 80 people who took it, and 60 of them got better, and 60 out of 80, if you could do that as a decimal, is 0.75, or 75%. So if the medicine worked, then it looks like the placebo works too, right? Because 75% of those people that had allergies and were given a fake pill, right, a placebo, they saw improvement in their allergies as well. So in order to really say the medicine works, we have to say it works better than a placebo effect. So sometimes you give people a pill and you tell them this is going to help you, and just that mental aspect makes them feel better. Or maybe 75% of people were just going to get better anyways, even if you didn't give them anything, right? So in order to say the medicine worked, you need to see that substantially higher percentage of people were getting better when they took the medicine than when they took the placebo, and we don't see any difference here at all. A big part of statistics is to answer questions like that. Does it look like the medicine is more effective than the placebo? So that's something for you to look forward to in stat, but I think it's worth a quick look here. All right, that wraps up this section.